Hello, a very warm welcome. Today we are looking at another LeetCode question, which is concatenation of consecutive binary numbers. And what the question says is we are given integer n and we need to return a decimal value of the binary string found by concatenating the binary representations of 1 to n in the modulo 10 to the power 9 plus 7. Okay, so what does that mean is if we are given a number n, we need to go each and every number till the value n and need to convert that into a binary, append it to each other, append it to each other, and then again convert it back to the decimal value. What do I mean by that is, let's take example 3, right? If we are given number 3, we are having 3 digits to it, 1, 2 and 3, which corresponds to a value 1, 1 0 and 1 1. This is a binary translation of 1 to 3 decimal values. Now if I append 1 1 0 and 1 1, it turns out to be 1 1 0 1 1, which corresponds to 27, right? So if so how what does that mean, right? So say if I'm given a number 4, right? So I have to take 1 2 3 and 4. This becomes 1, this becomes 1 and 0, this becomes 1 and 1, this becomes 1 0 0, right? So what is my updated string will be? That will be 1 1 0 1 1 1 0 0, right? I appended 1 1 0 1 1, so this is 1, this is 1, this is 1, this is 1. Now once I have this, I'll have to kind of convert it back to the decimal, which in this case will be, if I convert it back to this, right? Once you calculate it, it becomes 220, right? So now on the first go, right, the very simple thing which comes to mind, okay, iterate through each and every values in the given number until we reach that number, convert that to binary, append it, and once I have the updated list, updated string, uh, convert it back to decimal and then give the results. So what do I mean by that is, with the same example, right? 1 2 3, if I have 1 1 0 1 1, I have this string str, right? So I add value of 1 to it, and I do something like this, okay? Str plus equal to the given binary of the number, right? So what will happen, right? First str will be 1, then it will become 1 append whatever I'm getting, 1 1 0, then 1 1 0 1 1. But problem with this will be, right, this is a humongous operation. It is going to be very taxing from the performance perspective. First to convert that to binary, then append it, because then you are always going to create a new uh, new allocate a new space in the heap, and then once you have that final string with you, you again perform very humongous task to kind of bring it back to the decimal places. You can go ahead and try that, but I'm definitely sure that, okay, this is going to break once you're trying to do the submission, because that will always break in terms of performance, that okay, this is something which is not accepted. Now how to mitigate this? So how we're going to approach this problem is, I am given a value 1, right? So this is 1, right? This binary representation is again 1. If I look at 2, right, this is equal to 1 and 0, right? In this case, my overall string becomes 1 1 0, right? So what does that mean is, means once I concatenate 1 and 2, my this 1, I mean this 1 got shifted by 2 positions, correct? Now if I look at another 3 which becomes 1 1, then this 1 is again shifted by 2 positions, right? Now this is at this position, this place, right? Now what does that mean is my index of this, which was earlier say 0, is now at 3, now at 5, and if I add another 4, which is equal to say 100, will be 110111100, will be moved by 3 positions more. This is 8 now. That means my index of 1 is always shifting by the length of the binary representation of the number, right? So let me pen it down in the notepad for better clarity. Just said was I had a value 1, right? This is 1. Now I have a value 2. This binary representation is 1 0. Overall string becomes 1 1 0. If I have string 3, it is 1 1. Overall string becomes 1 1 0. Let me bring a space in between, 1 1, right? This is my overall string now, right? What this value corresponds to? This corresponds to a value of 6. If I convert it back to decimal, this corresponds to value of 27. Now again, as I said earlier, right, my integer bit, this bit is shifting by the length of the binary representation of this one, right? So I can break down this by saying, okay, my current index, right, is whatever my value which I was having earlier, which in this case was 1, right? Then I'll do, okay, this is multiplied by whatever my value 2, as in the modulo 2, to the power of the digits, or you can say binary representation of current number, right, plus number itself. So what does that mean is, if I compute that further, right, this becomes 1 into 2 to the power the binary representation of this was 1 0, whose length is 2 plus 2, this becomes 6, right? Now let's see if this formula works for us in the next one as well. So what I'm looking for is something which is 27. Sorry, this was 27, right? Now again, what I said was whatever my current number is, which in this case is 6, right? Whatever my previous overall sum came in was, which was 6 into 2 to the power the length binary representation of the current number, 3 11, this is 1 1, which is 2 again, right, plus whatever my current number is, which is 3. So this becomes 6 into 24 plus 3, this is 27, right? Let's take another number. This is 100. My update number becomes 1 1 0 1 1 1 0 0, right? This time this particular number got shifted by 3 positions. So what was the number at previous calculation, which was 27, right? So this becomes 27 into 2 to the power the number of digits which I had, which is 3, plus my current number, which is 4. This becomes 27 into 2 to the power 3, in this case is 8, plus 4, this becomes 856, 8 to the 16, 21 6, 2 to 0, right? So with this, I think you're getting where I'm getting at. So if I'm at a given index, whatever that number is, convert that to binary, get length, and apply above formula, right? and we need to just keep on going ahead, and we'll also talk about the modular part of it, but let's discuss that. So let's come to the code. Okay, so herein what we need to do is we need to first see, okay, what is my mod. My modulation is 1 10 to the power 9 plus 7, I believe. Yes, so 1 1 2 3 4 6 7 8 9 2 3 4 5 6 7 8 9 1 2 3 4 5 6 7 8 9, because I'm adding 7 to it. Now what I'm saying is, okay, whatever my sum, whichever is going to be, which I'm going to calculate. Now what I'll do is, okay, for my int I is equal to 1, I less than equal to the number which is given to me, I plus plus, and what I need to do first is I need to find out whatever is the length of the binary representation of this number, binary len, right? Now in C sharp we have this functionality wherein if I do dot to string and whatever my current index by 2, it converts that to the binary. And I think in Java we have convert dot to binary string, and similarly there are different inbuilt functionalities in different languages, right? So this is nothing but conversion of this number I to the binary part of it. Once I have that, I need to get the length of it. I got the length. Now what was my formula was? My formula was my initial sum, or my sum, into math dot power 2 comma binary len plus my current number, right? Binary len, which is nothing but your length of the binary representation. Now once I have that, I'll do sum, I'll do the same thing, sum into, now I need to ensure this is integer, math dot power 2 comma binary len, and once I have this, plus my I, right? And the very important thing which we need to always keep a note of, that okay, if it goes greater than the given number, I have to always do a mod of it, right? Mod, right? So this is it. This will ultimately give us the final results to whatever I'm looking at. So return, considering that was, I created that as a long, return this. I got this. Let's run it for, that's fine, let's submit it. It got accepted. Now if you look at the time complexity, that will be O of n, and space complexity will be O of 1. Thank you guys. I think if you have any questions, any doubts, please go ahead and write in the comment section. I'll try to resolve them. And in case you like the explanation, please go ahead and like and subscribe. Thank you. Thanks a lot.